All right, now we divided chapter 12 into 3 parts. First part dealt with the various ways of measuring with the various gases and liquids or solutions, whatever it is we're looking at there. The second one dealt with the actual concentration formulas, and the third one dealt with, or is going to deal with, what we call colligative properties. Colligative properties are properties that affect the physical properties of solutions, particularly a solvent, and how the solvent changes with the fact that it becomes a solution because of all the bonding that the solvent molecules have to make with the solute. It'll change some of these physical properties fairly dramatically. The first one we're going to talk about today is what was known as Roguel's law. Now, this is what we're going to be doing our lab on, is this particular law. This is all about vapor pressure. Now, how that works is that just because something is not boiling doesn't mean it doesn't evaporate. I mean, if you put a bowl of water outside for some animals and no animals come around, but if it's a hot summer day, you go out and notice that either that it's completely gone or mostly gone. And it wasn't because it was so hot that the water's boiling. If that were the case, we'd all be dead. It is the fact that when solar energy attacks a solution, it'll cause the particles to vibrate. The vibration causes the bonds to break, and then the water molecules then are able to come off as vapor molecules, which is kind of the equivalent of steam. Well, it is steam, but not hot steam. It's just steam at a temperature that allows it to move around. And it can very easily recondense, which is why in the summertime we can actually feel sticky, because a lot of the moisture will turn around and reform water on whatever surface it collides with, and it'll stick to it. Skin is polar, water is polar, it likes polar surfaces, it'll stick to you, and we just go there because you feel kind of nasty and sticky. But that's how it works. So every substance, no matter what the temperature, has a certain amount of vapor pressure involved in it. Now, most of the solution that we deal with is water. When we talk about weather, which is what we're going to be dealing with for Raoult's law in the lab, we're definitely talking about weather solution, but it doesn't have to be. And there may be problems that deal with that in the homework. So, Raoult's law states that the change in concentration of the solvent in terms of mole fraction is proportional to the decrease in vapor pressure. And what that means is this. The formula pretty much explains it all. Your pressure of your solvent after a change in temperature and a change in concentration of solute and solvent, but we're going to focus on the solvent part of it. The pressure of the solvent, which is the vapor pressure, is going to equal to the original vapor pressure of your solvent times the mole fraction of the solvent after you've added a solute to it. So we're dealing with mole fraction again. And this is an example. Example, if you have vapor pressure of pure water at 25 degrees Celsius is 23.8 torr. So let's put that down. So this is the original vapor pressure of water. And that's 23.8 torr. And we have to remember that vapor pressure changes with temperature. The higher the temperature, the higher the vapor pressure, because you have more vibrations of the molecules and more likely bonds are going to be broken. Okay? Since 50 grams of sodium chloride is added to 100 grams of water, what would be the resulting vapor pressure at that temperature? So 25 degrees Celsius, that's it. Although the 25 degrees Celsius is not going to have any value, but in the back of your book, one of the first appendices we have back there, there's a list of vapor pressures for various temperatures. And that is something we're going to be referring to in the lab. But that has nothing to do with the formula. We've got 50 grams of sodium chloride and 100 grams of water. So 50.0 grams of NaCl and 100 grams of water. And since we're involving vapor pressure of water, this is what we actually need to find out in order to get to the new pressure of the H2O. What's the new vapor pressure going to be? Okay, so in order to find this out, we have to change both of these to moles. So we go to our periodic tables, sodium is 23.0 and chlorine is 35.5. So this gives us 58.5 grams per 1 mole of sodium chloride. And it would probably help if I cancel the grams out. So I got that reversed. So 1 mole on top and 58.5 grams on bottom. And the answer is something like 0.867 or something, but I'll check it when we get to that point. 100 grams of water, multiply that by 1 mole over 18.0 grams. And this is going to give us something like 5.56 moles. Let me check on that answer for the first one here. 0.855 moles. Okay, I was off a bit on that one. So 0.855. So the mole fraction of water is going to be the moles of water on top, 5.56, over the sum of these two, so it'll be 0.3 moles, 0.855 plus 5.56 moles. This is not a percent, we leave it in fractional form, and the moles cancel out. So come back over here, check this out, and the answer we get for that is 0.867. That's where I got 0.867 from, okay? 0.867. All right? So, the vapor pressure of the water at 25 degrees Celsius at this concentration then is going to be the original vapor pressure, which we said was 23.8 torr, or millimeters of mercury if you prefer, times the mole fraction of the water, which is 0.867. And so we go back to this, and we know it's going to drop by about 13%. And the value you get is 20.3 torr. So this is 20.3 torr. So that means then that we've lost 3.5. So let's just call this change of vapor pressure. It doesn't ask for it, but I think one of your questions will actually ask you that. So I will just go ahead and do this. So the change in vapor pressure is the final, which is 20.3 torr, minus the initial, which is 23.8 torr. And so it's a loss of 3.5 torr. Change. And that's what's going to happen when you add a solute to a solvent. The vapor pressure is going to decrease as long as the temperature stays the same. And the reason why is now you've got it bound up to something else. This is why, and we're going to talk about this in the next discussion, why when you add solute to something like water, any kind of solvent, what will happen is that the boiling point is going to increase because it's going to take more energy to break those bonds to get to that boiling point, which is defined as the temperature at which vapor pressure and atmospheric pressure are the same. And we'll get into that in the next one. The bottom line here is you have some practice problems related to Raoult's law here on 5960 on page 548. Good luck.